In this video, I'm going to answer the question, what do software engineers actually do? Now, you might be confused because people on YouTube, they've been, I think, promoting like a false lifestyle of just drinking fancy coffee and eating fancy free food and not working. And that just hasn't been my experience. So let's talk about it. So, actually here, so typical day for a software engineer, you show up to the office around 8:30, anywhere from 8:30 to 10:30, and you go home anywhere from 4:45 to 6:30. And the reason for this is basically, unless you have certain meetings at certain times of the day, you do have a lot of flexibility in general about around when you go to the office, because the main thing that matters is your job performance and your availability to your teammates. So as long as you're finishing your tickets assigned to you with good quality and good speed, it doesn't really, like, the fact you show up at 10:30 doesn't really matter. Some people show up later just because they live further away and they need to beat the traffic. Or not beat the traffic, I guess, like avoid the traffic. Some people leave earlier to beat the traffic, some people show up later to avoid the traffic. Do you also say beat the traffic in that case? Anyways, some people just avoid the traffic and they show up at different times. But the main thing that matters is, so you could work at home before you come to the office, or you could work later at night after you leave the office. It doesn't really matter, at least in my experience. Maybe there's some really nitpicking managers and companies out there that really care, but for my experience, it doesn't really matter too much what time you show up, and what time you leave. What matters, though, is your work output. Software engineering can pretty much be a remote job, unless the company, demands you to be in the office. But otherwise, you just need your computer and an internet connection to push code and edit code and write code reviews for your team. So anyways, that's like a typical schedule. I know, like, a lot of managers I've met, like, work a lot more than this. But I've just been an IC, individual contributor, and this is kind of the schedule I see. And some people, like, really slack off and just, like, leave really early and show up really late and just, like, barely do anything, and, good luck to them. Okay, so what do software engineers do during their day? I would say these first four are the main components of time. As you get to higher levels, you attend more and more meetings, but we'll talk about that in a second. So software engineers spend a lot of time reading code. Generally with software engineers, if you're working as a software engineer, you're assigned, like, tickets. You're assigned, they call them tickets, just like tasks of work that are assigned to you that you need to do. And they call them tickets. They're usually JIRAs, or whatever it doesn't really matter. They're just tickets. They just say, like, hey, if the ticket should be written well. If it's not written well, then you need to send it back to whoever wrote it and say, hey, like, what is the problem? What's the acceptance criteria, etc. Because if you don't know what you're supposed to do, or you don't know what the acceptance criteria is, or you don't know what the problem is, then, like, how are you supposed to know what to do? So anyways, reading code. So when you're assigned a ticket, you generally need to figure out, like, what is going on. Like, usually either it's a bug and there's something going wrong in the code for customers, or it's just something that QA detected or someone detected that's going wrong before customers found it, which would be great, because you don't want customers to find the issue, because they're like the end. You want to find issues before it gets to the customer or the end user, because you want the end user to be very happy and for things to not go wrong for the end user. Then your company will be happy, you'll be happy. You won't be happy if customers find bugs in the code that you wrote, because then people higher up in the company will see it, and your manager will see it, and it won't be fun for you. So but I guess I'm not really talking about reading code. So anyways, reading code, if you're assigned a ticket, you need to figure out like where in the code base you need to make changes. Either you're familiar with that area of the code base already and you know where to make the change, or you are unfamiliar with that area and you need to read code in that area to figure out like what's going on, what the code is, what functions are involved, what's needed, why the code is written a certain way. You might need to go back and look at the Git history or the history using your version control system and check why code was written this way. You might need to look at the main contributing authors to the files you're looking at. Look at their past PRs, or just reach out and ask those people questions. Maybe, I don't know, if you have a question about why the code is written a certain way, you can reach out to the author of that code and ask them. So anyways, you spend a lot of time reading code. It's not just like typing away at the keyboard clickety clack all day. There's a lot of like reading and investigating. But after like the reading and investigating, then you can get to like the writing. And writing code is usually not the most time-consuming thing. Usually the most time-consuming thing is like reading code and understanding it, as well as designing code. Writing code, software engineers need to write code. But again, like writing code is easier. It's like if you need to plan out a trip to get to Alaska, you need to do a lot of planning before you actually, like, I would say reading code is like planning how to get to Alaska and like booking the train tickets, or not train, I'm sorry, booking the, I don't know, Ubers to the airport, and then flights, and then maybe trains, maybe trains from Canada to Alaska or something. Also, like reading code is like booking all those things. Then writing the code is like after you have everything booked out and mapped out, then you just like hop on the plane, hop on the train, hop in your car. So like reading code is like figuring out like what to do, what to fix. And then writing code is just actually writing it down. I don't know if that makes sense. I'm sorry, I tried. Same with designing code. I guess I kind of probably overlapped reading code, but like for designing code, I guess you'll sometimes be given like larger code features to implement, as opposed to just like a bug to fix. And when you're given larger features to implement, you need to come up with a design. You need to draw out different components of the system and how they're going to interact with each other. When you're designing code, I mean, it's usually because your feature is going to be adding some new component or adding on some like data to a request or something like that. And you might be interacting with different systems. You might be making requests to different systems, and you need to figure out like what the new, it might be introducing new APIs that you need to spec out. You need to define the inputs and the outputs and how they behave and possible failure scenarios. So that's kind of like what designing code is. And then usually after you're done like coming up with your design, you need to talk about your design with your teammates and usually other teammates, or not teammates, your teammates and other teams, members of on other teams, to discuss your solution and to see like what works, what doesn't work with your solution. And then you'll make revisions to your draft until eventually you get all stakeholders like reasonably happy with your approach. So yeah. And then you attend meetings like any other normal corporate job, talk about your status, meet with your manager, meet with your coworkers to talk about things. When I say talk about things, I mean like maybe they need help from you solving something that they're doing, or you need help from them solving something that you're doing. And then, the companies I worked at have not had like crazy food options, but yeah, usually places have snacks. So yeah, people get up, get coffee, get snacks, nothing crazy, and then you just go back to your desk and keep working. And I put walks here also. Um, so a lot of times, software engineers and then probably other desk workers too, at tech companies and other companies, a lot of people just sit all day at their desk, and a lot of people now are like starting to do the standing desk thing, but most people just sit at their desk all day and stare at their computer screen, 2 feet away from their face, and it's not the best for your posture or your eyesight. And so, getting out and walking is a nice thing to do to help yourself feel better. So people just like walk around their building sometimes for like 15 minutes and then go back to their desk. Probably like once a day. I would say up to once a day. Yeah, so let's see. Generally, software engineers solve problems, and they're given. I'd say they're given freedom how to do it. So yeah, like I said earlier, you're just kind of given a ticket with a problem, and then you need to kind of figure out how to do it. And I would say like some things have more freedom on how to solve them than others. And when I say have freedom, I mean there might really only be like one viable real solution, and you just need to implement it. Whereas if you're designing a new feature, there's likely going to be more freedom for like how the implementation can look. Or there can be, how do I say it? There can be more than one solution, and you as the implementer and like the designer need to figure out like what you think is best and kind of push for it, and state like why you think your design is good, and you need to be able to stand or like defend your design to other software engineers and say like why your design is good and how you've thought about potential pitfalls with your design, I guess. But in general, yeah, it's not like there's a set procedure for anything you do. Everything's pretty open-ended. Even though usually there's like how do I say it? I guess for bugs, there's like a sort of defined like acceptance criteria typically, but I guess for new features though, there's not really. It's a little more flexible. But what I'm trying to say, it's not like you're doing an oil change on a car, where it's like there's like these steps you follow to do the oil change, and then you charge the customer the money. This is a lot more freedom is given. It's like I was comparing it to Legos earlier. Like you can think of the code base as like a world full of Legos, and there's like moving parts in it. And then if you're adding a new feature, you're basically adding a new set of not adding a new set of Legos, but you're adding on Legos to this existing world. And I don't know if that's a good example, but I don't know. I don't know what I'm trying to say. I'm just trying to say like when you're writing code, you usually have more freedom on how to do it. There's no like set. Like everything you're doing is basically okay. That's not true. I was gonna say everything you're doing has basically never been done before. But that's not true. Sometimes there are a lot of things you do that are similar to past things that have been done. But a lot of things you do in software engineering, they're all like brand new. Not brand new, like you're inventing it, but like it's just like in your code base, just like this exact thing has never been done before, and so versus like if you're doing an oil change on a 2010 Honda Civic, then it's like okay, you've probably done this like 100 times before, and you know what to do. But in coding, like everything's like pretty new usually. Usually you're adding some new data to a class, or you're updating a function, or that hasn't like, it's just the things you do haven't been done before, and that's why you need to do it. Yeah, it's a lot of fun. So, okay, my next slide is on knowledge, and I said this is the hard part. This is why software engineers get paid a lot of money, I think. This is why it's hard to be a software engineer. Like usually the coursework in college is hard, just the studies are hard. There's a lot of things you have to know as a software engineer, and Okay. I think software engineering is hard, but or like becoming a software engineer is hard. The interview process is hard, and the college coursework is hard. But like, I don't know. I think like anyone can do it if you just like sit down and study. You have to be willing to sacrifice some things in college, like parties and drinking and stuff like that. Um, or well, not okay, not entirely, but like you need to be pretty responsible. You can't just not study and pass unless you're just like a really gifted human for some reason. But that's not 95% of people or 99% of people. So anyways, what am I trying to say? So for knowledge, like there's a lot of things that happen in computers that you need to know about, and you need to know different software technologies and how those technologies interact with each other. You need to know how computers work, and in what scenarios computers work well and what scenarios computers don't work well. What scenarios technologies work well and what scenarios those same technologies do not work well. Because all the technologies you use as a software engineer, they have pros and cons. You need to be able to understand those pros and cons and discuss those things when you're writing code or creating a new project or starting a new company. Um, so, yeah. I feel like software engineering is pretty similar to life. It's a very open-ended world, and you can kind of create whatever you want in it. There's a lot of technologies that do different things, but sometimes those technologies don't interact well with each other. And sometimes certain technologies like make things too complex and they're too hard to use. Or not too hard to use, but just some technologies take longer to learn, or they're too expensive to use, or they just don't work for your particular use case. And like these kind of things, like you just need to understand. Like you need to understand how like the internals of a computer work, how computer memory works, the CPU works, how threads work, how like concurrent access to a system works, how user logins work, authentication, security features, and none of those things are too crazy. They're actually all pretty interesting and pretty fun to learn about. But anyways, sorry, I'm just rambling. So so there's a lot of knowledge you have to know about, which is just a lot of memorization. It's a lot of just like practicing these technologies yourselves, and that just comes through your schoolwork and internships and watching YouTube videos or whatever, Coursera videos or something. So yeah, okay. That's all the slides I had. So I hope that kind of answers what software engineers do. All right, please like, subscribe. Please, if you have any questions or anything, please write them in the comments so I know like what you think or what you like, what you don't like. Cool. All right, thank you. See you later.